Alright guys, welcome back to our second video of the week. Again, we're going to work on exponents and the rules and laws that are applied to them. Today we're going to work again on standard and expanded form. So let's take a look at our CLO. We're going to understand when two numerical expressions involving exponents are equivalent. We're going to apply these properties so that we can kind of work with them when we get to the power of a power, product of a power, power of a product, and a quotient rule. And then the y is know and apply the properties of integer exponents to generate equivalent numerical expressions. So that's kind of what we're going to really dip into here with our standard form into expanded form. Take a quick look here. This is, if you guys remember, up on the wall in the classroom, we had this poster up here. Go ahead, I'm going to link this into the weekly overview, so this will be linked in the overview, and then you guys can reference that, and in each video and each slide we're going to have this poster for us. Okay, it's got all the different laws and exponents. So again, this looks familiar here. X to the third power is the same as x once, twice, three times. X times x times x, three times. So we take a look here. 2 to the third. It's 2 times 2 times 2, three times. 2 times 2 is 4. Times 2 is 8. So it's not, remember, it's not 2 times 3. Exponents are not the same as multiplying by that, the base times the exponent. It's the base times itself, the same by the exponent. So it's whatever the exponent is, how many times the base is being multiplied by itself. Okay, so here we have standard form. We're pretty good at that. This is how it's typically seen. Standard form. That's a base with an exponent. We have our base and we have our exponent here. That's typical exponent standard form. Here we have expanded form. Let's take a look here. We have 12 to the second power. That is the same as 12 times 12. Once, twice. 12 times itself, two times. So that's what the exponent is telling us. How many times the base is multiplied by itself. This right here is expanded form. It's spread out. There's more numbers there. It's expanded. Okay. So let's take a look here. We have 9 to the 27th. Now this is kind of an example of why we use exponents. This would be really hard to write 9 times 9 times 9, 27 times. That would just go all the way, fill up this screen, come back here, all over here. That would be way too much, right? I don't want to spend that much time. That's why we use exponents. But here, just for the basic of understanding what we're doing here, 125 to the fourth power. That's the same as 125 times 125 times 125 times 125. We have it once, twice, 3, 4 times. That's how many times the base is being multiplied by itself. Okay? So here, you guys are going to practice these next few slides putting these into expanded form. They're in standard form. This is a base with an exponent. You got to take this and expand it, make it bigger, expand it out. What is this going to look like? Okay. Take 3 to the third and put that into expanded form. The base is 3, the exponent is 3. Let's take this and put it into expanded form. It is in standard. What's 4 to the third power? All right, check this out. 6 squared. Remember, 6 squared. Anything to the second power is squared. It's like we're finding an area. I have a rug and it's 6 feet on the length and the width. 6 squared. So this is standard form. What would that look like in expanded form? Ooh, 1/2. Can we have fractions and decimals that have exponents? Absolutely. What would 1/2 to the 4th power look like in expanded form? And then would this be really big or really small? I wonder. And finally, let's take a look at this one. Another fraction, 1/3 squared, 1/3 raised to the 2nd power. What will this look like?